people are really interested in what are the surprises that we're getting out of the Webb.
We have some images, and they're fine, but the spectroscopy blew us away.
The mysteries of space are vast and ever-evolving. Just when we think we have some answers, the cosmos throws a curveball, sparking our curiosity even more. And recently, with the help of James Webb Space Telescope, we've found something truly amazing in our neighboring galaxy. As the Milky Way and Andromeda are on a path to crash into each other in roughly 4.5 billion years, it appears Andromeda might have some secrets of its own to share. What message does Andromeda hold? And why is there a growing concern among the scientific community? Stick around until the end of this video, and all will be revealed.
See, that misty patch of light is not a cloud in the sky. It's not even gas and dust in our galaxy. That is another galaxy. It's the Andromeda galaxy, which is roughly the same size as our own, an island of hundreds of billions of stars, 25 million kilometers in that direction.
On a clear night, while the moon lights up the sky, there's something special and mysterious about the Andromeda galaxy. The James Webb Space Telescope, which made the recent discovery, is the most advanced telescope we have ever built. It was inspired by the Hubble telescope. Hubble itself was no small feat. Decades ago, it delivered revelations that reshaped our understanding of the universe. One such revelation was the astonishing details about Andromeda's size, offering us a clearer view of our galactic neighbor. But James Webb wasn't just designed to follow Hubble's footsteps. It aimed to leap bounds ahead, and it did. Previously, our knowledge of Andromeda's halo was akin to seeing the outline of an iceberg above water. But James Webb unveiled the massive submerged part. This halo was found to be 6 times more expansive and 1,000 times heavier than what we'd imagined. Now here's where the interest really begins to peak. If Andromeda, our neighboring galaxy, possesses such an immense halo, could our home, the Milky Way, also be haloed in a similar celestial glow? The implications are staggering. These two massive galaxies, Andromeda and the Milky Way, might be starting to mix together at their edges even before they fully meet. So it's like two separate stories that we thought would meet in the future, but are already beginning to overlap now. A long time ago, when telescopes were basic, astronomers saw a blurry spot in the sky. Charles Messier, in 1764, listed it on his map of the stars, but people weren't sure what it really was until the 1920s. That's when Harlow Shapley and Heber Curtis figured out that this spot, called Andromeda, wasn't just a group of stars inside our galaxy. Instead, it was a huge, separate galaxy all by itself. It all started to get questionable back in 2005 and 2007. With data gathered from watching the stars do their complicated dances, scientists were able to make estimates that set the stage for the future. Yet the cosmic curtains were not fully opened until 2015. It was then that the James Webb Space Telescope entered the scene and changed everything. At the same time, the Hubble Space Telescope provided us with a previously unseen view of Andromeda, showcasing the best of both artistic and scientific achievement. This image was a tribute to human intellect and innovation, as it was a mosaic of 7,398 exposures from 411 telescope pointings. It exposed dust formations and other fascinating features among the more than 100 million stars that make up the magnificent galaxy. Then again, it wasn't just about looks with this detailed image. It had the potential to solve the secrets of distant spiral galaxies. Without this image, it would have been far more difficult for scientists to determine the hidden structures of these galaxies. The truth still does not end there. It was decided to investigate the black hole actions of our neighboring galaxy, where 2017 saw the shocking finding of 2 supermassive black holes locked in an orbital dance, which amazed the scientific community. And because of the mysterious dynamics that govern these objects, this binary black hole pair was declared the most tightly bound pair in the cosmos. But what about the black holes that could be found under Andromeda? Well, in 2013, the Chandra X-ray telescope helped out and brought back a cosmic haul, 26 potential black hole candidates. At that point, it was the largest catch of its sort from beyond the Milky Way, revealing a previously undiscovered population that further enriched the mystery of our galaxy. Moving on, in 2016, NASA's Nuclear Spectroscopic Telescope Array joined the ranks as yet another cosmic sentinel. It did what it was designed to do: discover new objects using X-ray observations. To our understanding of the cosmos, it revealed 40 more black holes within Andromeda's region in 2017. Black holes were not yet the only source of surprise. In 2017, scientists speculated that they had found a pulsar, a dead star spinning at incredible rates. This finding, which was made possible by NASA's Swift satellite, added another chapter to the story of Andromeda. And the James Webb Space Telescope has since then played an integral role in each and every one of these revelations and discoveries. Today, the Andromeda Galaxy is the subject of a continuous cosmic story, and each new set of observations and a wave of research has peeled back another layer of its mysterious tapestry. So as we look back on recent history, several exciting discoveries have surfaced, each of which may provide a key to unlocking the mysteries within. Meanwhile, in 2011, exploration of infrared wavelengths provided a new glimpse into its heavenly history. As a result of these explorations, we now know that star birth and death unfold in a cosmic ballet soaked in interesting infrared colors. Then, in 2017, gamma-ray radiation, a hushed whisper that may indicate the presence of dark matter, sparked the imagination. Andromeda bears the cryptic imprint of this mysterious material, whose existence is known only by the effects it has on the ordinary stuff of the universe. But what about the halo of dwarf galaxies that surrounds this cosmic jewel, you may ask? For one, the scientific community started making assumptions about its likely presence surrounding our own Milky Way when this intriguing characteristic was found in 2013. It now appears like the universe is revealing its mysteries through the structures it has created out of stars and galaxies. Yet, the James Webb Space Telescope marks a turning point in astronomical history. It sheds new light on the mysteries of Andromeda like a cosmic beacon. Its existence broadens the horizons, giving researchers an effective new instrument with which to examine and comprehend this fascinating galaxy. The spectacular mass migration of stars converging towards Andromeda is currently being observed by the James Webb. Galaxies appear to be cosmic tinkerers, expanding by mergers over eons of time. The Magellanic Clouds and the Sagittarius dwarf spheroidal galaxy are slowly embracing one another in our own Milky Way as we speak. Still, the James Webb has uncovered a lot of treasure, if it comes down to whatever it has contributed so far. To begin with, there are around 7,000 stellar migrants known to exist among Andromeda's stars. This ancient tale of interplanetary mixing involves stars from the nearby galaxy M31 that crossed over into Andromeda some 2 billion years ago. With this finding, we can now see the stars for what they are, a record of the cosmos's past written in their fundamental structures. Though the James Webb isn't the only telescope helping us understand Andromeda. The Dark Energy Spectroscopic Instrument, or DESI, was also created to investigate the relationship between the expansion of the cosmos and the mysterious dark energy. DESI has carefully mapped the paths of roughly 7,500 stars in Andromeda's halo, following the threads of their journey through time like a cosmic artist. Having said that, as we go deeper into the appealing domain of the Andromeda Galaxy, we come upon one more tempting element of it: its abundant supply of globular clusters. Whereas if you were to understand it much more simply, imagine these star clusters as cosmic gems. They are closely packed groups of stars that orbit the center of the galaxy, similar to satellites that revolve around a planet. And the numbers are mind-boggling. Andromeda is home to approximately 460 of these ancient, densely packed clusters. Each of these clusters contains hundreds of thousands or possibly millions of stars that were all formed at the same time. Additionally, this treasure mine of globular clusters acts as a time capsule, providing a look into the cosmic past of Andromeda. As a result, it has been involved in a cosmic dance for billions of years, during which it has interacted with other smaller galaxies. Now, this connection gives the impression of galactic cannibalism, as when less massive galaxies approach the gravitational sphere of Andromeda, enormous forces rob them of their stellar and material wealth. One of the most mysterious elements of our universe is dark matter. While we can't directly see it, its gravitational effects influence galaxies, including Andromeda and the Milky Way. Studies suggest that around Andromeda, there's a colossal halo of dark matter, extending perhaps 1,000,000 light-years from its center. This invisible halo might be playing a significant role in the inevitable collision between our two galaxies. Around the colossal Andromeda, there are several dwarf galaxies that orbit it, much like satellites. Two of the most notable are M32 and M110. These galaxies have their own tales of survival, evolution, and interaction with the much larger Andromeda. M32 in particular has an intriguingly compact and dense nucleus, leading scientists to hypothesize that it might once have been a much larger galaxy that underwent a close encounter with Andromeda, losing much of its stars in the process. As galaxies like Andromeda interact and consume smaller galaxies, they leave behind remnants known as stellar streams. These streams are essentially paths of stars that once belonged to other galaxies, but are now stretched and torn due to gravitational forces. Exploring these streams is akin to looking at galactic fossils, providing a history of Andromeda's past meals and interactions. Both Andromeda and the Milky Way are part of a much larger cosmic structure, known as the Laniakea supercluster. Encompassing about 100,000 galaxies, this supercluster is a colossal web of cosmic matter, bound together by gravity. As we speculate about the future of Andromeda and the Milky Way, we must also consider the destiny of this grand cosmic structure. As galaxies within it interact, merge, or drift apart, the supercluster itself evolves, providing an ever-changing cosmic panorama. Andromeda's celestial population has been strengthened as a result of the absorption of stars from other galaxies that it has consumed, which adds to the galaxy's complex fabric of starry threads. This fascinating phenomenon is also a defining characteristic of spiral galaxies like Andromeda, which have a structure similar to a disk and spiral arms that are easily identifiable. It is the ideal setting for encounters of many kinds, including mergers, with more tiny cosmic neighbors. But there's always more, isn't it? Astronomers have been left with tempting questions considering recent discoveries and painstaking analyses. It would appear that the galaxy known as Andromeda is in the process of undergoing a cosmic change, transitioning from a conventional spiral galaxy into something uncommon yet fascinating, a ring galaxy. These heavenly marvels can be identified by the circular or elliptical ring-like structures that they possess. These characteristics serve as a sort of celestial fingerprint that identifies them. So imagine this. There is a central location that has a relatively low concentration of glowing matter, and all the way around it is a dazzling, vibrant ring of young, bright blue stars. These ring galaxies stand out from the rest of the cosmic population thanks to the spectacular display that they put on. But even within the world of ring galaxies, there is a great deal of variety, given there are the O-type and the P-type as the main types. Now, galaxies with an O-type ring structure have nuclei that are centered, and the rings of these galaxies have smooth, regular contours. On the other hand, P-type ring galaxies have nuclei that are located off-center, and their rings have a tendency to be more uneven, which lends them an appealing appearance. These ring galaxies are extremely rare in the cosmos. Only around 1 in 10,000 galaxies can obtain the categorization of ring galaxies. But how do these marvels of the cosmos come into existence? There are two primary hypotheses that explain their formation, both of which are captivating. The first explanation points to the dramatic collision of two or more galaxies. As these massive celestial entities approach one another, drawn by their gravitational pull, a cataclysmic interaction ensues. This tremendous collision doesn't resemble a crash as we might imagine on Earth. Instead, these galaxies undergo a dance where their gravitational forces pull, tug, and distort their structures. Over millions of years, this dance can lead to the formation of the spectacular rings that make ring galaxies so distinct. It's a cosmic ballet, where the aftermath is a magnificent ring structure that leaves astronomers and stargazers in awe. The second hypothesis paints another vivid picture. Imagine a smaller galaxy daring to pass directly through the heart of a much larger one. As this smaller galaxy journeys through the center of its larger counterpart, it leaves behind a wake of disruption. The gravitational forces at play during this passage can pull and stretch the larger galaxy's stars, gas, and dust, creating the iconic ring structure. It's akin to throwing a stone in a pond, and the ripples that emanate outward form the ring we observe from a distance. Beyond the fascinating origins of ring galaxies, the story of Andromeda and our very own Milky Way offers another gripping chapter. Although the Milky Way and Andromeda are separated by about 2.5 million light-years, they are moving towards each other at an astonishing speed of approximately 110 kilometers per second. The thought itself is mind-boggling. These two galactic behemoths, with their vastness and grandeur, are gradually inching closer, set on a collision path that will redefine our understanding of time and space. As they continue their approach over millions of years, they will not merely collide but entwine, spiral, and merge, engaging in a cosmic waltz. The outcome? The birth of an entirely new galaxy, formed from the remnants of these two great celestial entities. When these two supermassive black holes get within a light year of each other, they create an arrangement of gravitational waves, an astonishing display. These space-time tremors then echo, sending forth a cosmic hug to all of existence. And as their orbits draw closer to one another, the resulting bursts of energy set off a gravitational tango that ultimately ends in a merger. Of course, they will eventually collide, creating a hotspot of energy and mass known as the active galactic nucleus. But where does our solar system fit into this cosmic movement? For starters, there is an equal possibility that our solar system will be 3 times further from the galactic center in this newly united galaxy than it is now. Imagine the Sun, the Earth, and the rest of the solar system at the very end of one of the spiral arms of the galaxy, the Orion Spur. Yet, there is a twist in this cosmic drama. It is also possible, according to scientific projections, that our solar system will be completely evacuated from the newborn galaxy. This path, although a cosmic walk into the unknown, does have a certain lyrical beauty to it. The legacy of humanity still will be nothing more than a faint echo in the cosmic fabric by that time. But don't worry, our solar system has nothing to fear from a cosmic departure of this sort. It wouldn't have any effect on the Sun or any of the planets, asteroids, or comets that joined it on its cosmic journey. Instead, it would be business as usual. And even though astronomers may argue and analyze several aspects of the cosmos, there is one topic on which they can all agree: the size of Andromeda. It is a fabric that reaches further than our very own Milky Way, and it holds the throne with dimensions that are beyond understanding. The estimated width of our Milky Way, which ranges from 100,000 to 175,000 light-years, is reduced in size by its reach, which covers an astonishing circumference of around 220,000 light-years. So, in this celestial competition, Andromeda comes first as a huge presence that dominates its section of space and earns the title of a gigantic celestial monster. On the other hand, the universe unfolds more fully before our very eyes as a result of this discovery. The limitless variety of things that can be found in the universe can be seen in the intricate web of galaxies, each of which is magnificent in its own way. Andromeda's immense magnitude presents a picture of the cosmos's glory and carves out a big region within the fabric of the universe. But even as we are awestruck by the magnitude of Andromeda, we have to face a harsh reality: the difficulty of accurately estimating the size of galaxies. So as we continue to look out over the cosmos, the revelations about Andromeda and its massive dimensions serve to remind us of the cosmic wonderland that is all around us, where James Webb not only provides us an understanding of the vastness of faraway galaxies, but also of the mysteries that motivate our efforts to understand the complicated structure of the cosmos. So what else does the James Webb Telescope have in store for us? Let us know in the comments below. To catch us for more such updates, simply hit the bell icon.